Who is Isaac Newton? He was an English mathematician, physicist and astronomer, born on 4th January 1643, in a little town of Lincolnshire. He has always been fascinated by science, and this led to a brilliant career as some of the most important scientific discoveries of all time. He is famous for his extensive work on gravity, mechanics, optics, thermodynamics and calculus. Maybe some of you may know the 3 laws of motion that he published. So now let's describe them and see how fundamental they are in our everyday life. The first one states that in an inertial frame of reference, an object either remains at rest or continues to move at a constant velocity unless acted upon by a force. So we can say that an object, if not subjected to a force, maintains its starting behavior of motion. This law can be seen, for example, playing hockey on ice. If the disc is moving and no other forces are applied to it, it will continue moving in the same direction. The second law states that in an inertial frame of reference, the resulting force F of an object is equal to the mass m of that object multiplied by the acceleration a of the object. So we can write this famous formula. This can be also written like this, meaning that the rate of change of momentum of a body is directly proportional to the force applied. This change in momentum takes place in the direction of the applied force. But this law can be also stated in terms of a body acceleration, so the force is also directly proportional to the mass and acceleration of the object. For example, when a racket hits a tennis ball, the ball has an acceleration thanks to the force that the racket applies to it. Now consider a ball with a greater mass and the same force applied by the racket. In this case, the acceleration will be lower. It states that when one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. One of the coolest applications of this law is the rocket engine. The two objects are the engine itself and the gases created by the combustion. Not the air as many people think. So the hot gases are accelerated in one direction and the rocket will obtain a force in the opposite one. The fact that the rocket uses gases created in the combustion and not the air allows it to work properly also in the vacuum of space. We hope that now you will see the world with different eyes. I hope you liked the video. If you have any suggestion about new content, let me know in the comment section. If you enjoyed the video, give a thumbs up, and if you are new to the channel, subscribe. See you in the next video. Physics laws are fundamental in order to understand what surrounds us and how to solve different problems. In this first video we are going to see 5 of the most important laws with some real-life applications. Meanwhile, in a second video we will introduce other 5 important laws. The first one is Archimedes' principle. It states that the upward buoyant force that is exerted on a body immersed in a fluid is equal to the weight of the fluid that the body displaces. It's very important in fields like fluid mechanics. For example, it's fundamental to understand why a boat does not sink despite the extremely high weight. Indeed, a boat displaces a huge amount of water, and for this reason it will have a force to counterbalance the weight of the boat itself. To compute the buoyant force, it's sufficient to apply this easy formula, where ρ represents the density of the fluid, g the acceleration due to gravity, and v is the volume of the displaced fluid. Now let's analyze Pascal's law. It's a principle useful in fluid mechanics dealing with transmission of fluid pressure. It states that the pressure change at any point in a confined incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. So, considering the fact that the pressure change is transmitted everywhere, lowering the area of a piston gives us lower forces. Meanwhile, increasing the surface of the piston increases the force developed. This observation is the principle behind hydraulic lifting and pressing devices. for example hydraulic jack and hydraulic press. But you also use this principle every day when you are using the braking system of your car. Now let's briefly talk about Doppler effect. Basically, it's the change in frequency of a wave in relation to an observer due to the relative motion between the source and the observer. To understand this concept practically, you can think about an ambulance with the siren switched on, passing near you. During the approach, the frequency perceived by you is higher, and will be identical in the exact time in which the ambulance is passing by. And finally, it will be lower while the ambulance is going away. The reason behind this effect is that when the source of wave, the ambulance in this case, is moving towards the observer, each successive wave crest is emitted from a position closer to the observer than the crest of the previous wave. So each wave takes less time to reach the observer than the previous one, causing an increase in frequency. Let's change topic now with Coulomb law. This is an experimental law useful to quantify the amount of force between two stationary and electrically charged particles. The force that is generated between charged bodies is called Coulomb force. In the scalar form, this is the formula. Ke is Coulomb's constant, and the value of this constant is 9 times 10 to 9 Newton meter squared over Coulomb. Meanwhile, Q1 and Q2 are the magnitude of the charges, and R is the distance between them. Now we can also introduce the Fleming rule, also known as right-hand rule. It's very useful to find the direction of induced current when a conductor attached to a circuit that moves in a magnetic field. It's called right-hand rule because in order to find the direction of the induced current, you will use the first three fingers of your right hand. The thumb is pointing the direction of the motion of the conductor relative to the magnetic field. The first finger is pointing in the direction of the magnetic field, and finally the second finger represents the direction of the induced current through the conductor. This figure is a representation of how you should point your fingers. Generally speaking, the Fleming rule can be used to determine the direction of the vector resulting from the cross-product operation between two vectors. That's it for the first part of this topic. Stay tuned to learn more. Please subscribe and leave a like if you enjoyed the video. In this second part, we're going to see 5 more important physics laws. If you're not done yet, go check the first part. Let's start with the Kepler laws of planetary motion. Kepler published 3 different laws in order to describe the motion of planets around the Sun properly. The first one states that the orbit of a planet is an ellipse, with the Sun at one of the 2 foci. The second one states that a line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. From the second law, it's possible to understand that when a planet is closer to the Sun, it travels faster. Finally, the last of the 3 laws states that the ratio of the square of an object's orbital period over the cube of the semi-major of its orbit is the same for all objects orbiting the same thing. All these 3 laws are vastly used every day in space and astronomic fields. An important principle for fluid is Bernoulli's principle. It states that an increase in speed of a fluid occurs simultaneously with a decrease in static pressure. So the speed of the fluid is inversely proportional to the static pressure. An application of this principle is the floor of an F1 car, for example. The increase of the velocity of the flow results in a decrease of the pressure, and so it creates a forces point down called downforce. Now let's talk about electromagnetism. Introducing Faraday's law. It's very important in order to predict how a magnetic field will interact with an electric circuit to produce an electromotive force, usually called EMF. This is due to a phenomenon called electromagnetic induction. So what does this law state? It states that the electromotive force around a closed path is equal to the negative of the time rate of change of the magnetic flux enclosed by the path. The electromotive force is indicated with epsilon, meanwhile the magnetic flux with phi. This law is the basis of the operation for transformers, inductors and a lot of electrical motors. Another fundamental law to always keep in mind is the conservation of energy. Indeed, it states that the total energy of an isolated system remains constant, and so it will be conserved over time. A famous sentence with which it's known is energy can neither be created nor destroyed, rather it can only be transformed or transferred from one form to another. An everyday example can be seen playing pool. The first ball is shot at another stationary ball, and so the energy transfers from the first ball to the second, putting the second one into motion, neglecting the heat due to friction. The first ball loses kinetic energy because the energy has been transferred to the second, and so it will slow down. And finally, the last but not the least law of this video, we're talking about Hooke's law. It states that the force needed to extend or compress spring by some distance x is directly proportional to the distance, so the formula will be this one. K is a constant, and it represents the stiffness of the spring, and it could change depending on the type of the spring. You can observe that the extension of the spring is proportional to the force applied, so in this case, doubling the mass, the extension of the spring doubles. If you are also interested in Newton laws, you can check my other video in which I explain Newton's free laws with some interesting application. If you like this video, please leave a like and remember to subscribe. Every day we are used to see airplanes flying in the sky. But how is it possible that these giant vehicles that can reach a weight of 500 tons are able to fly? The answer is quite easy. It's thanks to aerodynamics. Even if the answer is simple, the concepts behind this phenomena are very complex and need a huge amount of study from the engineers. Obviously, doing all the studies and tests on real aircraft is not possible due to the high operating cost. For this reason, aerospace manufacturers use wind tunnels. The great thing of modern era is that even a personal computer with a dedicated software is able to simulate the real airflow behavior. This software uses a technology called CFD that stands for Computational Fluid Dynamics, solving numerically complex differential equations. So, let's explain this phenomena using simplified equations. First of all, we are considering air as an incompressible fluid, because in doing so, it's valid the Bernoulli equation. The Bernoulli equation states that increasing the speed of the fluid, the static pressure decreases and vice versa. Now, considering an airfoil in a horizontal airflow coming from this direction, we can observe that in these two areas the velocity drops, and so the pressure rises. Meanwhile, in these other two areas, the velocity rises, and so the pressure drops. So, if we represent the relative pressure, we obtain a distribution like this one. Note that the pressure above the airfoil is lower than the pressure below. For this reason, there is a net vertical force, the lift. Similarly, near the left part of the airfoil, the pressure is higher than in the right part, so it results in a horizontal force called drag. The problem is that the lift may be too small in this configuration, because in order to fly horizontally, it has to be equal to the weight of the aircraft. A better configuration can be obtained increasing the angle of the airflow in respect of the flow. In order to doing so in a CFD software, it's possible to change the direction of the velocity vector of the airflow, called angle of attack. We're able to do so because we will get the same results. We can see that the velocity in this area is much higher than the previous one, giving us a lower pressure and so higher lift. The disadvantage is that it will also produce higher drag. There is a limit on how much we can increase the angle of attack, because over a certain limit, typically 12 degrees, there is a phenomenon called stall. The stall occurs when the airflow separates from the surface of the wing, resulting in less lift and higher drag. Moreover, looking at the CFD results, we can see that this is the separation region. Another disadvantage of higher angle of attack can be found analyzing the 3D behavior of the airfoil. The difference in pressure near the wing tip forces the air below the wing in the upper part, creating huge vortices causing a lot of induced drag. Obviously, the engineers have found a solution to block this process. It consists in using winglets, that are devices that you always see at the end of the wing. We hope that after seeing this video, the next time you will be on an airplane, you will be more conscious about the physics behind it. If you are curious about engineering facts, follow these 2 pages on Instagram. Have a good day! In this video, we are going to learn what is a transmission system, how it works, and why it's useful in the automotive field. We will see 3 types of transmission system. For example, this Bugatti Chiron has a 7-speed dual-clutch transmission that is a type of automatic transmission. Moreover, we will also see a manual transmission and the more exotic CVT transmission. CVT stands for Continuous Variable Transmission. Generally speaking, the transmission system is a device which provides controlled application of power in various conditions. It uses complex gear system in order to convert speed and torque from a rotating power source to another part, in this case the wheels. So the question is, why is it useful in a motor vehicle? Basically, the answer is that the rotation provided by the internal combustion engine needs to be adapted for the drive wheels. For example, a petrol engine operates at very high rotational speed, usually over a range of 1000 to 7000 rpm, while the wheels rotate usually at a maximum of 2000 rpm. So the job of the transmission system is to reduce the higher engine speed to this lower wheel speed. This process is useful in order to increase the torque, so that the system can supply high torque at low speeds, but staying also between the engine RPM limit at high speeds. Okay, you are starting to understand why a transmission system is needed, but we didn't say where it's mounted and how it works. The transmission usually is connected to the engine crankshaft through a clutch or a flywheel. The output of the transmission is transmitted thanks to the drive shaft to one or more differentials, which drives the wheels. The differential's purpose is to permit the wheels to rotate at different speeds, in order to avoid wheel spinning during cornering. Perfect, now that I've given you some background about transmission, let's start to focus on the various types of transmission system. The first one is the manual. Manual transmission is the most common type because it's very cheap and light. But at the same time, the other types usually give better fuel economy. It uses a driver-operated clutch, usually engaged and disengaged by a foot pedal, for regulating power and torque transfer. Meanwhile, the gear can be chosen through a gear selector, operated by hand. So the difference between an automatic transmission is that the driver has to operate the gear stick and clutch in order to change gears. Now, let's try to understand how it works when our car is moving, with this simple animation, where you can see the gear selector in action. The top shaft is coming from the engine crankshaft and it's rotating at about 4000 rpm. Meanwhile, the bottom one is rotating at about 2000 rpm thanks to the gears in the transmission. You have to consider that the flywheel is attached to the engine's crankshaft and so rotating at engine speed. The clutch is between the flywheels and the transmission input shaft, enabling and disabling the connection between the engine and the transmission. When the engine is running and the clutch is engaged, the flywheel spins the clutch plate and so the transmission. Keep in mind that engage means that the clutch pedal is not pressed. Meanwhile, if it's necessary a change of gear, it's sufficient to disengage the clutch pressing the clutch pedal, then select the gear needed using the gear stick, and finally release the clutch pedal. In doing this, you have changed the transmission ratio and so the vehicle can deliver the perfect torque also for different speeds. Now let's analyze how an automatic transmission works. The basic difference is that it automatically changes the gear ratio as the vehicle moves, as the name suggests. This means that the driver neither have to press the clutch pedal nor change gear by hand. As you can see, it's composed by an input, an intermediate shaft and the output. In this case, it's a 6-speed automatic gearbox, meaning that it has 6 gears plus the reverse. These are the clutch's plates and are useful in order to engage and disengage the planetary gears. Each clutch is put into motion using pressurized hydraulic fluid. Now let's see this animation in order to see how the gear changes. It works thanks to the different configuration that the clutches use. In doing so, it's able to pass from the first gear to the second and so on until the 6th gear, and even the reverse. Maybe you are wondering, why should I prefer an automatic transmission to a manual one? The advantage of an automatic transmission is the lack of a clutch pedal and a manual gear stick. This allows the driver to not focus on these two steps, increasing the attention on the road. Moreover, an automatic transmission increases the life of the system because it changes the gear perfectly, without any human errors that could wear the gear and the clutch. Changing perfectly the gear, it also improves the overall performance and efficiency of the vehicle. A particular type of automatic transmission is the CVT, that stands for Continuously Variable Transmission. It can smoothly alter its gear ratio by varying the diameter of belts, chain-linked pulleys, wheels or cones. This type of transmission is very interesting due to the fact that it's possible to achieve theoretically an infinite and continuous range of transmission ratios. Some automotive brands such that Toyota and Lexus have developed an electronically controlled CVT called eCVT. In this system, the transmission has fixed gears, but the ratio of wheel speed to engine speed can be continuously varied by controlling the speed of the third input to a differential, using electrical motor generators. Finally, let's talk about the problem related to the transmission system in which you may run into. The classic warning signs are vibration and strange noises. If you notice that your car has trouble accelerating or moving at all, but you can hear the engine speed up or rev, it could be the transmission gear slipping. Another warning sign is if the gear stick in your car is difficult to get into gears, causing noises during the changing. In this case, the transmission is either about to fail or has already failed. Continue to talk about problems, also strange smells are a wake-up call. Indeed, a burning smell could be a problem related to the transmission fluid. Sometimes the transmission fluid could also start leaking, reducing the pressure inside the transmission, causing damage and extra wear, increasing the risk of overheating. Remember to like the video and subscribe to this channel if you like this content. Thank you for watching, see you in the next video. Welcome guys! In today's video we're going to see and analyze 7 of the best technologies that are going to change our world in the future. We're going to see artificial intelligence, blockchain, virtual and augmented reality, IoT, data science, cloud computing, and intelligent apps. Let's start with the first one. Artificial intelligence, also called AI, is basically intelligence demonstrated by machines. It could be a strange concept considering that we are used to consider the intelligence as a natural thing. So let's try to understand how it works. We can define as intelligent any device which perceives its environment and acts in order to maximize its probability of successfully achieving its goals. For example, by interpreting external data and learning from them, they finally use the things learned to achieve specific goals and tasks thanks to the flexible adaptation. The goal could be easily expressed in binary, for example 1 if the AI wins, or 0 if it loses. Or in a more complex way, for example, do an action which is mathematically similar to the ones that succeeded in the past. Obviously, the impact of artificial intelligence on the world is not yet defined, and the long-term economic effects are uncertain. The negative side is for sure the increase of unemployment, but on the other side it could also be a benefit, for example in improving healthcare, increasing the efficiency of farming, improving the climate conditions, and minimizing the risk in all the fields. Moreover, while automation eliminates all jobs, it also creates new jobs through microeconomic and macroeconomic effects. Finally, the worst possible scenario is the possibility that AI could evolve to the point that humans could not control it. Let's pass to the second technology, blockchain. It's a growing list of records called blocks that are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. By design, a blockchain is resistant to modification of the data. It's an open distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. It is usually managed by a peer-to-peer network collectively adhering to a protocol for inter-node communication and validating new blocks. Internet of Things. and it's a term used to describe sensor, software and other technologies that exchange data with the internet to fulfill their purposes. This kind of technology has several applications. They are widely used in smart homes to pursue home automation. You can think of smart light, heating system, media systems, air conditioners, and even washing machines. Another application of IoT is in elder care. There are devices that can aid those with disabilities by helping with voice control features, enhancing the capabilities of the assisted person. Moreover, experimental devices in transportation system are under development. For example, smart traffic control, smart parking, electronic toll collection system, and road assistance. If you think that IoT has no application in the industrial sector, think again. Indeed, there are manufacturing systems equipped with devices capable to connect off the web, allowing an optimization of the supply chain network, thanks to the interaction of the various machinery part of the production company. There are a number of serious concerns about dangers in the growth of IoT, especially in the area of privacy and security, and consequently industry and governmental moves to address these concerns have begun, including the development of international standards. Cloud computing is a very useful technology that allows even low-end computers to have extremely high capabilities thanks to decentralized computing resources available on the internet. We have two types of so-called cloud computing applications. We have cloud storage, where digital data is stored in huge servers usually located in multiple locations managed by hosting companies. This service keeps the data accessible and available to its users. This kind of application is based on the selling or leasing of storage capacity from the company issuing the service. Famous examples of cloud storage service are Google Drive and OneDrive by Microsoft. The other application is computing Welcome to this new series on advanced technologies in electrical engineering. In this video and in the following videos, we will cover smart grids, wireless power transmission, and electric vehicles. In today's video, we'll talk about smart grid. Let's start by describing what a smart grid is. Basically, it is an innovative electrical grid that relies on multiple devices and energy measures with the objective of improved efficiency of quality of service. It is basically a two-way dialogue where information and electricity are transmitted to and from users. Let's define the historical context. The first alternating current power grid system was installed in 1886 in Massachusetts. At that time, the grid was a centralized, unidirectional system of electrical power transmission, electricity distribution, and demand-driven control. So it was a central generation device connected to a series of users. The regulation of the power was managed by looking at the demand of current over time. This design philosophy was not fault-tolerant. If the generator failed, all the grid suffered a power shortage. One in the afternoon, just after work, and the other just after average bedtime. In this short period of time, most of the vehicles are charging, so we have an excessive demand of energy on the grid. However, thanks to the smart grid concept and the use of smart charger connected to the internet, it's possible to change the curve, avoiding the excessive stress in the grid, allowing roughly 50 gigawatts of saving for every 2050 million electric vehicles. Considering an average 2.5 megawatt for wind turbine, we can compute how many turbines we are saving thanks to smart grid. It is sufficient to divide the power saved by the average output, obtaining roughly 20,000 wind turbines. You will learn more about electric vehicles in my next video on advanced technologies in electrical engineering. Another example could be the integration of solar panels into the national grid. The output of the solar grid is variable by nature and can be approximated by the sinusoidal function. When the output is getting lower, the generation of electricity has to be substituted by other energy sources, for example, hydroelectric power generation. However, in this case, the ideal output is not constant, but it has to match the typical demand of the grid during a day. In a typical US grid, we can use this graph. We have a morning ramp when all the industries start their shifts, and we have a peak in the late afternoon when people come back from work and start using their electrical appliances. So we have to match the curve of demand and offer by regulating the power of the generators using smart sensors. With green we have the solar power, and in blue the hydroelectric power. Finally, let's analyze the economics behind this technology. In 2009, the US smart grid industry was valued at about $21.4 billion. By 2021, it will exceed at least $60 billion. Given the success of smart grid in the US, the world market is expected to grow at a faster rate. A 2011 research concludes that investment in a US smart grid will cost up to $476 billion over 20 years, but will provide up to $2 trillion in customer benefits over that time. The use of a smart grid carries several advantages. As mentioned in previous example, it's very efficient. It is reliable thanks to the use of technologies such as the state estimation that improve fault detection and allows self-healing of the network without the intervention of technicians. This will ensure more reliable supply of electricity and reduce vulnerability to natural disasters or attack. Moreover, thanks to bidirectional energy flows, it allows distributed generation, such as from solar panels on roofs of houses. The excess energy is sold in the network, allowing a potential earning from the household. The disadvantages are mainly related to privacy concern with data management from energy companies. However, several laws are presented to protect the data of the users. The concept of smart grid is already operative in the United States, Germany, United Kingdom, and China. However, several countries are deploying smart grids, such as Canada, France, Italy, Spain, Japan, Norway, and Sweden. Well, that's it for this video. If you liked it, subscribe to this channel and stay tuned for the next video on electric cars. Remember to leave a like on the video and let me know your thoughts in the comment section below. See you next time. Welcome guys! In this video we're going to analyze what is an electric vehicle and how it works. Moreover, at the end of the video we will talk about wireless power transmission and its applications. So, what is an electric vehicle? Basically, it's a vehicle which uses one or more electric motors or traction motors for propulsion. It may be powered in two different ways. The first one is through a collector system by electricity from off-vehicle sources, or may be powered by batteries, solar panels and fuel cell contained direct into it. There exist electric vehicles for a lot of different scenarios. For example, the most common are road and rail vehicles, but also underwater vessel aircrafts and even electric spacecrafts. EVs first came into existence in 19th century, but nowadays they have been more and more famous due to technological developments and an increased focus on renewable energy, in order to decrease the impact of vehicles on climate change. One of the most common technology used in electric vehicles are lithium-ion batteries. Indeed, most EV use this type of battery because they have high density, longer lifespan and higher power density in respect to other batteries. Obviously, there are also some drawbacks. For example, safety, thermal breakdown and cost. Indeed, lithium-ion batteries must work within a specific temperature and voltage range in order to be safe and efficient. A very important thing to keep in mind while talking about electric vehicles is the functioning of the electric motor. As a common internal combustion engine, its power is expressed in kilowatts. But the advantage of the electric motor is that they are able to deliver their maximum torque over a wide RPM range, meaning that they are able to deliver the maximum torque even when a common vehicle equipped with an internal combustion engine can't. To clarify this concept, let's consider two vehicles, one completely electric and the second with an internal combustion engine, both standing still. The first one will have better performance at the start, because in this condition it's very important to deliver all the possible torque in shortest possible time. And obviously, the electric vehicle will get the maximum torque as soon as the driver pushes the throttle. While the driver in the second car will have to wait the right RPM range before getting the maximum torque available. Another thing to keep in mind is that the process of converting electrical energy into mechanical energy doesn't come with no losses. Approximately 90% of the energy from the batteries is converted to mechanical energy, and the losses are especially in the motor and drivetrain. Usually, EV vehicles have an efficiency of about 60%, in respect to conventional gasoline vehicles, which have a much lower efficiency with just 20%. The key point is the environmental advantage over combustion engine. Indeed, EVs release no tailpipe air pollutants at the place where they are operated. So, as we said, electric vehicles are much more efficient and moreover they also produce less direct emission. But are EV really emission-free? Well, the short answer is no. They do rely on electrical energy that is generally provided by a combination of non-fossil fuel plants and fossil fuel plants. So EVs are charged with electricity that is generated by means that have health and environmental impacts. Consequently, EVs can be made less polluting overall by modifying the source of electricity. In some areas, consumers can ask utilities to provide their electricity from renewable energy. We can conclude stating that the air emission from producing and operating an EV can be less than or greater than those of producing and operating a conventional vehicle, depending on the regional electricity grid mix, timing of EV charging, driving patterns, climate, the set of air emission under consideration, and the specific electrical and conventional vehicle designs being compared. Now, let's use the concept of smart grid seen in previous video in order to analyze this very interesting idea. Since EVs can be plugged into the electric grid when not in use, there is a potential for battery-powered vehicles to even cut the demand for electricity by feeding electricity into the grid from their batteries during peak use periods, such as mid-afternoon air conditioning use, while doing most of their charging at night when there is unused generating capacity. This vehicle-to-grid connection has the potential to reduce the need for new power plants, as long as vehicle owners do not mind reducing the life of their batteries by being drained by the power company during peak demand. Well, the question now is, how have the nation reacted to this new technology? In May 2017, India was the first to announce plans to sell only electric vehicles by 2030. With nearly a third of all cars sold in 2017 of all new cars either fully electric or a hybrid, Norway is the world leader in the adoption of electric cars, and like India pushes to sell only electric or hybrid cars by 2030. The other nations followed the lead, with France and the UK announcing the plan to ban the sale of gas and diesel cars by 2040. Austria, China, Denmark, Germany, Ireland, Japan, Netherlands, Portugal, Korea and Spain have also set official targets for electric car sales. Many governments offer incentives to promote the use of electric vehicles with the goals of reducing air pollution and oil consumption. Some incentives intend to increase purchase of electric vehicles by offsetting the purchase price with a grant. Other incentives include lower tax rates or exemption from certain taxes and investment in charging infrastructure. Another interesting concept is the wireless power transmission, or electromagnetic power transfer. It is the transmission of electrical energy without wires, which are usually used as a physical link. In a wireless power transmission system, a transmitter device driven by electric power from a power source generates a time-varying electromagnetic field, which transmits power across space to a receiver device, which extracts power from the field and supplies it to an electric load. This technology could be fundamental in order to reduce drastically the use of the wires and batteries, thus increasing the mobility, convenience and safety of an electronic device for all users. Wireless power techniques mainly fall into two categories: near field and far field. In the first one, the power is transferred over short distances by magnetic fields using inductive coupling between coils of wires or by electric fields using capacitive coupling between metal electrodes. In far field, also called power beaming, power is transferred by beams of electromagnetic radiation, like microwaves or laser beams. In this way, it's possible to transport energy for longer distances if properly aimed at the receiver. For example, a useful application are solar power satellites. The problem of this kind of technology is that it could be dangerous for living beings, and for this reason it's important to limit the exposure of them to the electromagnetic field. Well, that's it for this video. I hope that it has been useful for you. If you liked it, please leave a like and tell me in the comments what do you think about these technologies. Moreover, do not forget to subscribe to my channel. See you in the next video.